In this lesson, we'll be reviewing how to use the Q equation to solve for different variables, including Q, the heat energy, and also the change in temperature. So, we can start off by remembering what the Q equation is. Q equation is Q, that's heat energy, is equal to M, mass in grams, times C, the specific heat capacity, and delta T, that's the change in temperature. So, I'm going to write it out here. Q is equal to heat energy in joules. You could also might have it in calories also, but usually we'll keep it in joules because that is a standard unit. I'm going to show you one example where we do have it in calories. Then we have M is the mass in grams. CSP, you could just put C also, is the specific heat capacity. Specific, it's kind of weird there, specific heat capacity, that's how much energy it takes to change the temperature of 1 gram of substance by 1 degree Celsius or Kelvin. Remember, for water, it was always 4.184 joules per gram Celsius. And then our delta T is change in temperature. So technically, you could use either Celsius or Kelvin for this because they're going to be the same number. The change in is going to be the same number. But I usually like to keep it as Celsius because that's the easiest thing to measure. Alright, so we're going to do our first practice problem, which is right down here. Pull that up there. Okay. It says the specific heat of iron is approximately 0.45 joules per gram Celsius. There should be a little degree sign there, but I couldn't find it on this keyboard. But pretend that's degrees Celsius, or you could have a Kelvin. How much heat energy is required to raise a 10-gram sample of iron from 40 degrees Celsius to 0.95 degrees Celsius? So let's write out what we know. And what are we trying to find? It says how much heat energy, so that's what we're trying to find. So that's our Q. So we're going to put Q as our question mark. That's what we're trying to find. And remember, the equation was Q equals MC delta T. You can put that CSP if you want, but you can just, for right now, we know that C is going to be specific heat. Then we have our mass, which is M. In this case, that mass is going to be the 10 grams. 10 grams. It's already in grams, so that's fantastic. Our C, our specific heat, remember, it tells you that at the beginning the specific heat of iron is 0.45 joules per gram Celsius. This they give this in joules, so we know our Q is definitely going to be in joules as well. So it's going to be 0.45 joules per gram Celsius. I'll put a little degree sign right there. And our delta T is our change in temperature. So it went from 40 degrees to 95 degrees. Remember, we take our final and then we subtract from our initial. So it would be 95 minus 40 is equal to, 95 minus 40 is going to be 55 degrees Celsius. And if you put it to Kelvin, you just do 95 plus 273 minus 40 plus 273, and it's just going to end up being 55 also. Alright, so let me actually move over here a bit, give myself a little bit more room, but I can still see the numbers. So let's write this out. We have, I'm going to write it in a different color. Let's do green. Alright, so we have Q is equal to, remember our mass was 10 grams, 10G, times, and we have our C is 0.45, and it says it's joules on the top over grams degree Celsius, and then times 55 degrees Celsius. So if you notice right here, you can actually cross out some units. You know you have grams on the top right there, but grams on the bottom. So you know those things will cross out. And you have Celsius right here, and you have Celsius on the Celsius right here, and Celsius on the bottom. So you know those will cross out because anything, this is being basically divided out, so those will cross out. So our only unit that's left is the joules. So let me pull up a calculator right here to figure this out. Alright, so we just got Q is equal to 10 times 0.45 times 55. And that should give us 247.5. So that's going to be Q is equal to 247.5 joules. Alright, so now we're going to move on to our next problem. It's going to be a little different because it gives us different units and it's going to ask us for something different. It says if 100 calories of heat is added to 50 grams of water at 70 degrees Celsius, what is the final temperature of the water? So there's a couple things to know. For the sake of this, I'm actually going to convert this. Remember, it's given to us calories. We're not going to use calories. We're going to use joules. But if you do end up using calories, you can remember that the specific heat of water is just 1 calorie per joule. So let me actually I'm going to use a blue pen this time. So let's write out what we know and what we don't know. So see right here. So we have Q, our heat energy, is going to be, it's 100 calories, but we don't want to use calories right now because joules is the standard unit. So if we have 100 calories, we can actually just convert that into joules by doing, remember, it's 1 calorie is 4.184 joules, so you're going to do 100 calories times 4.184 joules over 1 calorie. And so the calories will cross out. 100 times 4.184. If you know multiplying by 100, you're just going to move over the decimal point 2 times. So it's going to be 418.4 joules. Alright, and then we have our M is equal to 50 grams. And then our C, remember our C of water is that 4.184 joules per gram Celsius. So this is going to be 4.184. This is one of the ones that we had asked you to memorize before. Joules per gram Celsius. Alright, and our delta T, our delta T would be our final minus our initial. In this case, we don't know our final, but we know our initial. So let me actually just put TF minus 70. So we don't know. We're trying to find out. We got to find out what delta T is first. Then from that, we got to find out what the final temperature is. So let's move this over just a bit. Let's see. So we can still see everything. All right. And I'll just move it a bit after. I'll change this to green now. So we have our Q, which is 418.4. I'll put joules there, is equal to, we have 50 grams, and then I'm going to actually have to move this a bit more. 50 grams times 4.184 joules over the gram degrees Celsius, and then times, we got to do delta T. So we got to figure out what delta T is here. So the way we could do this, again, you could have also just rearranged the equations of delta T's on the other side, but I'm going to just show it this way. So remember the grams and grams will cross out. So what we're going to do, we can multiply what we know together. 50 times 4.184. So let's take out a calculator. I'll do 50 times 4.184 is equal to 209.2. So let's write that. So again, this stays the same right here. 418.4 joules. And this is going to be, what was that? 209.2. And remember, the grams cross out, so now all we're left is joules over degrees Celsius times delta T. And so now we want to divide, we want to get rid of this 209.2 out here. And so in order to do that, we're going to divide both sides by 209.2. So let's take this out. So I'm going to divide out 209.2 with this 209.2. And then we're going to divide it by the joules degrees Celsius. So this whole thing crosses out. And we also got to do that over here, which is going to be 209.2 joules and then degrees Celsius. And if you notice that the joules and the joules, are going to cross out, and then when you divide by a fraction, this is actually going to come to the numerator, so this degrees Celsius is going to come to the top. So we have 418.4 divided by 29.2 is equal to 2. So we just have 2 degrees Celsius is equal to our delta T. And if you remember, we had delta T is equal to the T final minus 70. So let's write this out right here. So our delta T, we know that's 2 degrees Celsius. So we know it's 2 is equal to TF minus 70. And so to find our final, we got to make sure we get TF by itself. So we got to add 70 to both sides to get rid of it. So cross that out. So our answer is TF, our final temperature, is equal to 72 degrees Celsius.